Gauss theorem, also known by the name divergence theorem or Gauss divergence theorem, establishes relationship between surface integral and volume integral. Surface integral is the double integral, which is the integral evaluated over surface, and volume integral is the triple integral, which is evaluated over volume. The theorem says that when we have G, which is a solid bounded by a closed surface sigma, and F bar is the vector field across the surface, where F bar equals f of x y z into I plus g of x y z into j plus h of x y z into k, where f, g and h are the component functions of vector field F bar, such that f, g and h have continuous first order partial derivatives, and n bar is the unit outward normal with respect to the closed surface sigma. Then we have the surface integral, double integral over sigma f bar dot n ds can be equated to volume integral, triple integral over g divergence of f bar into dv. Notice that G is the solid and sigma is the closed surface which encloses the solid or bounds the solid. The term flux of a vector point function gives us volume of fluid crossing the surface per unit time. Suppose we consider a vector function which represents velocity of the fluid which flows across the surface. Then the surface integral, double integral over sigma f bar dot n ds, where sigma is the surface through which fluid flows and n is the outward unit normal with respect to surface sigma. F bar is the vector function with respect to the fluid, is known as flux integral. Since volume increases as speed of the fluid increases, we have flux will be proportional to the speed of the fluid flow. Similarly, flux will be proportional to area of the surface. In general, we have flux integral is nothing but the surface integral, double integral over sigma f bar dot n into ds. Stokes theorem establishes relationship between line integral and surface integral. Line integral is that integral which is evaluated along a curve. We have line integral evaluated over a closed curve will be circulation of the corresponding vector function across the closed curve C. For example, if you consider integral over C v bar dot dr, where v bar is the vector point function and C is the closed curve, then we have integral over C v bar dot dr is the circulation of vector v around the closed curve C. Whenever we consider a closed curve, we use a circle over the integral sign. Stokes theorem says that suppose S is an open surface bounded by a closed curve C and f bar, which is the vector field or vector point function whose components are f1, f2 and f3, so that f bar equals f1i plus f2j plus f3k, such that these component functions have continuous first order partial derivatives, then the line integral over C f bar dot dr can be equated to double integral over S curl of f dot n into ds, where n is the unit outward normal vector with respect to surface S. This is the surface integral over the surface S and this is the line integral over the closed curve C. These two integrals can be equated by following the Stokes theorem, which is applicable for open surface bounded by closed curve C.